We'll start in about a minute. Okay, today we'll review sections 1 and 2 from chapter 8 on simplifying expressions with roots. Starting with number 1, part A. Simplify the expressions with roots. This first one is the fourth root of x to the 28th. Oh, what does that simplify to? Okay, the index is 4. And inside the radical is x with an exponent of 28. 28 is a multiple of 4. So that means x to the 28th is a perfect fourth power. So to simplify, we write x to the 28 divided by 4, which is x to the 7th. It works in the reverse order. The fourth root of x to the 28th equals x to the 7th. In the same way that if you raise x to the 7th to the 4th, remember that property of exponents, x to the 7th to the 4th is x to the 4 times 7. And 4 times 7 is 28. I could have put an intermediate step here. The fourth root of x to the 28th is x to the 28 divided by 4, which simplifies to x to the 7th. Okay, part B, the square root of -9. So what is the square root of -9? Yeah, someone typed in 3i. That's true. We're not there yet. We're going to learn about that in a few days. But for now, we just say this number is not a real number. Not a real number. But we might as well take it one step further. The square root of -9 is the square root of 9 times the square root of -1. And in a few days, we'll learn more about the square root of -1. But for now, just note that the square root of -9 is not a real number. Okay, part C, the cubed root of -216. So what is the third root of negative 216? Yeah, the answer is negative 6. In the reverse order, if you raise the number negative 6 to the third, which means, since we have negative 6 in parentheses, it means negative 6 times negative 6 times negative 6, which is negative 216. Okay, the part D. So if you've already answered a question, then let someone else answer. Simplify the square root of 169 plus the square root of 256. So someone who hasn't answered yet, type in your answer. The square root of 169. 169 is a perfect square. That's one of those perfect squares that you should become familiar with. The square root of 169 is 13. The square root of 256 is 16. And then add those together. 13 plus 16 is 29. Okay, part E, the square root of 49 times x to the 10th. Both 49 and x to the 10th are perfect squares. The square root of 49 is 7, and the square root of x to the 10th is x to the 5th. Okay, the next one, part F, the cubed root of 8 plus the cubed root of negative 27. The cubed root of 8 is 2. The cubed root of negative 27 is negative 3. And then simplify 2 plus negative 3 to negative 1. Okay, part G. The fourth root of negative 625. The index of this radical is 4. So if the radicand is negative and the index is an even integer, then it's not a real number. So this is not a real number. Okay, in part H, we have the fifth root of negative 32. In this radical, the index is 5, which is an odd number. an odd integer, and the radicand is negative. So this number is a negative real number. It's a negative real number. Yeah, this one is -2. So in the reverse order, if you raise the number -2 to the 5th, so in parentheses, if -2 is in parentheses and the exponent is 5, it means -2 times -2 times -2 times -2 times -2, which is -32. Okay, in part I, the 6th root of x to the 30th. Okay, if you haven't had a chance to answer a question yet, go ahead and type in what you think the answer is for this one. The 6th root of x to the 30th. Okay, this simplifies to x to the 5th. Or we could, as an intermediate step, we could write this as x to the 30 divided by 6. And 30 divided by 6 is 5, so this is x to the 5th. Okay, the next one's pretty simple. The square root of 64 times m to the 14th. 64 is a perfect square, and so is m to the 14th. So the square root of 64 is 8, and the square root of m to the 14th is m to the 7th. So 8 times m to the 7th. So remember, the square root has an index of 2. So we could rewrite the square root of 64 m to the 14th as the second root of 8 to the 2nd times m to the 14. And then when you remove the radical, we have 8 to the 2 divided by 2 times m to the 14 divided by 2, or 8m to the 7th. That is probably more detail than you need, but that idea works in general. Okay, simplify the following. The square root of 81n to the 2nd plus the square root of 64n to the 2nd. The square root of 81 is 9. The square root of n to the 2nd is n. Then we're adding that to the square root of 64 n to the 2nd. The square root of 64 is 8. And the square root of n to the 2nd is n. And we can simplify further because we're adding like terms. So this simplifies to 17n. Okay, the next one, simplify the cubed root of 125 minus the cubed root of -64. So type in an answer for that in a few seconds. Okay, the cubed root, let's do it in parts. What's the cubed root of 125? Yeah, the cubed root of 125 is 5. An intermediate step could be the cubed root of 5 to the third. And then we're subtracting the cubed root of negative 64. Negative 64 is a perfect cube because if you raise the number negative 4 to the third, you get negative 64. And then the cubed root of 5 to the third is 5 to the 3 divided by 3. And then minus the number negative 4 to the 3 divided by 3. But 3 divided by 3 is just 1, so this is 5 to the first minus negative 4 to the first, or 5 plus 4, which is 9. Okay, so that simplifies to 9. Okay, on the next page, simplify the expressions. On the first page, everything was a perfect power. But this time, it's a little more complicated. So simplify the square root of 48. So first note, 48 is not a perfect square. So what we want to do, since it's a square root of 48, we want to find the largest factor of 48 that is a perfect square. Okay, so the largest factor of 48, that's a perfect square. The perfect squares are 1 to the second equals 1, 2 to the second equals 4, 3 to the second equals 9, 4 to the second equals 16, 5 to the second equals 25, and so on. So are any of those numbers, those perfect squares, factors of 48? Okay, I got a candidate on line 6. Six is not a perfect square. So the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, so on. So the largest factor of 48, that's a perfect square. 4 is a factor of 48, and 4 is a perfect square, but it's not the largest perfect square. 36 is a perfect square, but it's not a factor of 48. It's not a whole number factor of 48. So a hint is that it's smaller than 36. Okay, I got an answer, 16. 16 times 3 is 48. 16 is a perfect square. So the square root of 48 can be written as the square root of 16 times 3. And then remember, we have a product property of radicals. In general, if you have the nth root of a times b, you can write that as the nth root of a times the nth root of b. So we do that here. The square root of 16 times 3 is the square root of 16 times the square root of 3. And the square root of 16 is 4. And so our simplified result is 4 times the square root of 3. Okay, in part B, simplify the cubed root of 54. 54 is not a perfect cube. So to simplify this, if it can be simplified, we want to find the largest factor of 54 that is a perfect cube. Let's see, the perfect cubes are 1, 8, 27, 64, 125, and so on. Okay. 27 is a factor of 54. 27 times 2 is 54. And 27 is a perfect cube. 27 is 3 to the third. So we rewrite this as the cubed root of 27 times 2. And that's the cubed root of 27 times the cubed root of 2. Then we simplify the cubed root of 27 to 3. So our simplified result is 3 times the cubed root of 2. Okay, part C. Simplify the square root of 60 times m to the 31st. 60 is not a perfect square, and neither is m to the 31st. But they each have factors other than 1 that are perfect squares. So let's start with 60. What's the largest factor of 60 that is a perfect square? So I haven't seen any correct answers on YouTube yet for the largest factor of 60 that's a perfect square. So you can go through the smaller perfect squares. Well, 1 is a factor of everything. The next perfect square after 1 is 4. Is 4 a factor of 60? Yes, 4 times 15 is 60. And so since 4 times 15 is 60, and 15 doesn't have any perfect square factors other than 1, 4 is the largest factor of 60 that is a perfect square, the largest perfect square factor. Okay, the largest perfect square of m to the 31st. The exponent 31 is not even, so m to the 31st is not a perfect square. What's the largest factor of m to the 31st that is a perfect square? Yeah, it's m to the 30th. Okay, so let's rewrite this as the square root of 4 times m to the 30th times 15m what's inside the radical is equivalent to 60 m to the 31st if you were to multiply those. But I put the perfect square factors farther to the left. You don't have to do that if you don't want to, but in the next step, we'll write the simplified answer. The square root of 4 is 2. The square root of m to the 30th is m to the 30 divided by 2, or m to the 15th, and then times the square root of 15m. Okay, that's as far as we can simplify that one. Okay, the next one, simplify the fourth root of 32n to the 15th. So first find the largest factor of 32 that is a perfect fourth power, and then find the largest factor of n to the 15th that is a perfect fourth power. Start with 32. What's the largest factor of 32 that is a perfect fourth power? So the fourth powers are 1 to the 4th equals 1. 2 to the 4th, what's 2 to the 4th equal to? 16. 2 to the 4th is 16. 16 is a factor of 32. So 16 times 2 is 32. All right, so we found the factorization of 32 that we want, 16 times 2. And then what about the largest factor of n to the 15th that is a perfect fourth power? Okay, someone online who hasn't had a chance to answer a question yet, what's the largest factor of n to the 15th that is a perfect fourth power? If you have a variable with an exponent, how do you know that it's a perfect fourth power? If the exponent is a multiple of 4, then you know that it's a perfect fourth power. Well, at the moment, the exponent 15 is not a multiple of 4. So what's the largest factor of n to the 15th that is a perfect fourth power? There might be a connection that it might not be obvious when we consider perfect fourth powers of numbers like 32. It's sort of hidden, but it's the same thing that's going on with variables with exponents. So I'll use this example to illustrate what I mean. "32 is 2 to the 5th power. And a couple of minutes ago, we identified the largest factor of 2 to the 5th that is a perfect fourth power. It's 16, but another way to represent 16 is 2 to the 4th. And the exponent 4 is a multiple of 4. So we can rewrite the fourth root of 2 to the 5th times n to the 15th as the fourth root of 2 to the 4th. Okay, so the largest factor of n to the 15th that is a perfect fourth power is n to the 12th, because 12 is a multiple of 4. Okay, so this is another way to write what the fourth root of 32 n to the 15th is. And then the fourth root of 2 to the 4th is 2 to the 4 divided by 4. And then the fourth root of n to the 12th is n to the 12 divided by 4. And then we have the fourth root of 2n to the 3rd, which can't be simplified. Can't be simplified any further than that. 2 to the 4 divided by 4 is just 2 to the 1st, or 2. N to the 12 divided by 4 is n to the 3rd. So the final answer is 2n to the 3rd times the fourth root of 2n to the 3rd. So maybe this connection between numerical factors and algebraic factors, hopefully that helps, because it's the same thing going on, at least at the base level, even if you don't see it worked out that way. Okay, we have some rational expressions. So part E, simplify the square root of 6y to the 17th divided by 128x to the 10th. Notice that the rational expression inside the square root can be simplified. 6 over 128 can be written in lower terms. So I'll put in a intermediate step. Notice that 2 is a common factor of 6 and 128. So we can rewrite this as the square root of 2 times 3y to the 17th over 2 times 64 x to the 10th. And then 2 divided by 2 is 1, so those cancel. So we can just focus on simplifying what's left, 3y to the 17th, square root of 3y to the 17th over 64x to the 10th. Okay, so here we're going to apply the quotient property of radicals. I'll write that down in a couple of minutes, but the idea in general is if you have a radical with a fraction or a rational expression, you can write it as a ratio of radicals. Whoops. So the index is 2. You don't need to write the index 2 when it's 2. Okay, the denominator simplifies pretty nicely because both 64 and x to the 10th are perfect squares. And there's a little more work to do in the numerator. So in the next step, let's just go ahead and write the simplified denominator, the square root of 64x to the 10th. Square root of 64 is 8. Square root of x to the 10th is x to the 5th, because 10 divided by 2 is 5. And what about the numerator, the square root of 3y to the 17th? The largest factor of y to the 17th that's a perfect square is y to the 16th. So we can rewrite this as the square root of y to the 16th times the square root of 3y. And what does the square root of y to the 16th simplify to? So it simplifies to y to the 8th, because 16 divided by the index 2 is 8. 16 divided by 2 is 8, so it's y to the 8th times the square root of 3y. In the numerator, and the denominator is 8x to the 5th. Yes, so sometimes you can be tricked. The exponent 16 is a perfect square by itself, but we're taking the square root of y to the 16th. And if 16 is the exponent and the index is 2, when we simplify, we divide the exponent 16 by the index 2 to get y to the 8th. Yeah, so watch out for that. The next one, the cubed root of 81u to the 7th over v to the 15th. So let's rewrite it as a quotient of cubed roots, the cubed root of 81u to the 7th in the numerator, and the cubed root of v to the 15th in the denominator. So both the numerator and denominator can be simplified. The denominator simplifies pretty nicely because v to the 15th is a perfect third power. 15 is a multiple of 3. So we can simplify the denominator first. The third root of v to the 15th is v to the 15 divided by 3, or v to the 5th. And there's a little more work to do in the numerator. The largest factor of 81, that's a perfect third power. Well, 81 is 3 to the 4th. And so the largest factor of 3 to the 4th, that is a perfect cube, is 3 to the 3rd. 3 to the 3rd has an exponent of 3, which is a multiple of 3. Okay, so I'll write that in here. It's not absolutely necessary in every case, but 81 is 3 to the 4th. And just like we've been doing, if you have something raised to an exponent, the largest factor of 3 to the 4th that is a perfect cube is 3 to the 3rd. 3 to the 3rd times 3 is 3 to the 4th. What's the largest factor of u to the 7th that's a perfect cube? U to the 6th. Okay, so let's rewrite the numerator as the cubed root of 3 to the 3rd times u to the 6th multiplied by the cubed root of the remaining factors, 3 times u. And the denominator is already simplified to v to the 5th. And then finally, the cubed root of 3 to the 3rd is 3 to the 1st, or 3, because the exponent 3 divided by the index 3 is 1, times u to the 6 divided by 3, or 3u to the 2nd. And then we have to multiply 3u to the 2nd times the cubed root of 3u, and then divided by v to the 5th. Okay, the next one, simplify the square root of 312x to the 13th divided by 363y to the 6th. The numerator and denominator have a common factor other than 1. So 3 is a common factor of 312 and 363. So we can rewrite this as the square root of 3 times 104 times x to the 13th and over 3 times 121 y to the 6th. And then 3 divided by 3 is 1, so those factors cancel. And what do you notice? In the denominator, 121 is a perfect square. 11 to the 2nd is 121. Y to the 6th is a perfect square. So the denominator works out pretty nicely for us. So let's write the denominator as the square root of 121y to the 6th for now. And then in the numerator, what's the largest factor of 104 that is a perfect square? 4 is a perfect square. 4 times 26 is 104. And the largest factor of 26 is a perfect square is 1. So the largest factor of 104 that is a perfect square is 4. And the largest factor of x to the 13th that is a perfect square is x to the 12th. So let's rewrite the numerator, replacing the square root of 104 times x to the 13th. Replace that with the square root of 4 times x to the 12th times the square root of 26x. And then finally, we can write the simplified result. In the numerator, the square root of 4 is 2. The square root of x to the 12th is x to the 6th. And also in the numerator, we have to include the square root of 26x. And in the denominator, the square root of 121 times y to the 6th is 11y to the 3rd. Okay, part 8. Simplify the square root of x to the 6th divided by x to the 18th. We can simplify the fraction. So x to the 6th divided by x to the 18th. What does that simplify to? That simplifies to 1 over x to the 12th. So as an aside, if you look at x to the 6th times x to the 18th, the largest common factor is x to the 6th. X to the 18th is x to the 12th. X to the 12th times x to the 6th. And then x to the 6th divided by x to the 6th cancels. And then the square root of 1 over x to the 12th is the square root of 1 over the square root of x to the 12th. The square root of 1 is just 1. And in the denominator, the square root of x to the 12th is x to the 6th. Okay, the next one, the 5th root of n to the 25th over n to the 3rd. We can simplify the rational expression inside n to the 25th divided by n to the 3rd. Simplifies to n to the 22nd. So here we're subtracting the exponent 3 from the exponent 25. And then to simplify the 5th root of n to the 22nd, we want to find the largest factor of n to the 22nd that is a perfect 5th power. Okay, so n to the 20th is a perfect 5th power because 20 is a multiple of 5. So we can rewrite this as the 5th root of n to the 20th times n to the 2nd. And the 5th root of n to the 20th is n to the 20 divided by 5, or n to the 4th. And we multiply n to the 4th times the 5th root of n to the 2nd. So that is our final result. And we have a few seconds left. The 4th root of 81y to the 12th in the numerator divided by the 4th root of 625x to the 16th in the denominator. Well, everything in sight is a perfect fourth power. The fourth root of 81 is 3, because 3 to the fourth is 81. The fourth root of y to the 12th is y to the third, because 12 divided by 4 is 3. And in the denominator, the fourth root of 625 is 5. And the fourth root of x to the 16th is x to the fourth, because 16 divided by 4 is 4. Okay, we're out of time for today. Tomorrow we'll be in section 8.3.